All right, let's get started. Welcome to Galvanize DSI Premium Prep. This is a 5-week course. The weekday start times are going to be what's posted, right? Where we have, let's see, if we're in Pacific time, 6 to 8 p.m. Pacific, 7 to 9 p.m. Mountain time, which is where both Clark and I are located. Eastern time is going to be from 9 into 11, and Central time will be from 8 to 10. There are going to be recordings of everything, and I'll get to that when I get to it. Today, we're mostly going to be kind of like setting the groundwork for understanding what this course is for, how to best study, how to best approach the materials, and the resources, materials that are available to you, as well as things like mentoring, study halls, the various things that our team does to support you, and the things that you'll need to do in order to get ready for the DSI. Mostly in order to pass the technical interview, right? This is very geared toward that, and I'll talk about that at some length. So what I'm looking at right here is a GitHub repository under the Galvanize open source organization, and this is titled DSI Premium Prep, right? That's what we're looking at here. We're in the main directory of this, or the main branch of this. There are other branches. If you're familiar with GitHub, this is an archive of the most recent Premium Prep. There are links to the lecture videos from that Premium Prep. All the code is there. We do modify this and evolve the course as we go. So the things that exist in the January cohort, the one that just finished up last week, we're going to be doing things a little bit differently from that, but not so divergent that going back and looking at those materials isn't going to be beneficial. So let me, I'll just paste in into the thread this repository. This is kind of our source of truth. So I just want to tour you around this a little bit. Notice on this, let's see, where are we? Notice on this landing page, there's this Readme file, right? This is a file in the directory, and it renders on GitHub when you land at this location, at this URI. So, relevant details are all here, everything except for the Zoom password. We leave that in the Learn materials. But, we've got the Zoom link here. We have a link to our specific Learn materials here. There's a link to the data science, the Galvanize Data Science YouTube channel. I recommend you all follow that. Not just for our marketing desires, but when we do study halls, we go live on the YouTube channel. We stream via YouTube. And so if you want to get help immediately, you can jump in there, and if generally Clark is going to be leading those, and you can ask him questions in real time and code through solutions and have a conversation about why something works the way it does. It's a really good way to get yourself unstuck. There's also a link here to a playlist on YouTube of the recordings for this class. This is under our channel. This is funny. This is a link to the most recent playlist, which is not our current playlist, so I'll have to update that. But there exists an empty playlist, at the moment empty, on YouTube, where we are going to put the lectures from Premium Prep. So that's something I'll talk about a little bit more. There isn't much more to say about it, but that's where you'll go to watch recordings of these materials if you need to, if you want to. There's also a link here to our cohort on Learn. Learn is our learning platform. And so I just clicked through that, and notice this has the dates for our cohort from March 1st through April 3rd. There's a chance that we'll run a day extra and have a class on April 5th, the Monday after. There are times where we do that. We tend to do that with cohorts to either make up time or to make sure we cover the full extent of materials we wish to cover. That last class in general is going to be kind of a setting the stage and reviewing for the technical interview. So that last class kind of like we bring a lot of things together, and so we'll try to do that on April 3rd. If we have to run over and do April 5th, we'll let everybody know with a good couple weeks in advance so that you can allot that time. Okay, so let me get back to here. There's also this section we're back at the repo right here, the DSI Premium Prep repository. There's this set of links for other helpful resources. Now, there's a lot in here, and again, these are just helpful resources. These aren't homework materials or anything like that. The one thing that I'm going to strongly suggest you all do as soon as you can, aside from bookmarking this repository, which I definitely recommend, I suggest you use Chrome for this course. Chrome will be the web browser used in the DSI as well. I suggest you use Chrome, and I suggest you install this extension, MathJax plugin for GitHub. So I'm going to put that in our thread here. Put a link to that. There's also, some other things in here. Note-taking strategy that it's just a video of me talking about how do you take notes for something where you're essentially drinking from a fire hose. How do you organize your notes? And little secret here is you kind of don't, and you make everything in one document, and you Command F or Control F and find what you need on the fly when you need it. So this is a short video. I think it's like 15-20 minutes if you want to get into that. That kind of note-taking strategy I think is helpful for this course as well. We're going to start off slow, but we'll ramp up pretty quickly in the getting into the third week. Things will start moving in a bit of an inundationist sort of way. So you'll expect to be, kind of bombarded with new information. Not necessarily new, but not new to all of you, but new to some of you. What else in here? Yeah, and everything else in here is, JB Statistics is a great site if you want to walk through some of the derivations for statistical concepts, which we won't be doing too much of here. I do a little bit of that, but, given time constraints, we'll usually make supplemental videos for things like that. And if you want a different perspective on the same materials, JB Statistics is really good. There are a couple links to books here that are kind of seminal works in machine learning. Introduction to Statistical Learning and Elements of Statistical Learning. One of these is an undergrad text, the other is a graduate text. We will only be touching on concepts in these. There's a reading assignment, an optional reading assignment in the 5th week of class where I'll say, hey, go read these sections from the ISLR, which is how we refer to this book. And we'll be covering concepts in that. Khan Academy, if you want to brush up on algebra and calculus, which is going to be very helpful for the DSI. You won't really need that for this course, though, just to be clear. And what else? Just a couple other things that are, I think, interesting and helpful when you need them, like a graphing app and a derivative calculator. I think this site is actually pretty amazing, but also not necessary for this class, unless you're trying to perform integration on fairly complex functions and you want to be able to do that on the fly. And then some algorithmic, a view of some algorithms. So these are just supplemental links, other helpful resources as it's titled here. There's a schedule on this landing page in the README, and we have this, itemized by day. We have a set of tasks for homework here, right? So today's homework, we'll, kind of go over this toward the end of class, but, it's basically a task list. Go ahead and do these things. I should really put this one as being optional, but, everything here will want you to do that in the next couple days. And as we go forward, notice we've got links to the slide decks that we're going to be using. And with that, I'm going to actually click over to one of our slide decks, the slide deck for today, which is one of them is Welcome to Premium Prep. The other one is Introduction to Python. We're going to get through this Welcome to Premium Prep slide deck. We're probably not going to get through this whole Introduction to Python slide deck. So first thing you might notice about this is also in the repository, right? All of our slides are in the repository, and they're in a format called Markdown. This is how Markdown renders in GitHub, so it's kind of nice, and we can look at it as if it's slides, right? We can just do that. If you wanted to see what these look like under the hood, they look like this. So slightly less readable, slightly less rendered. You don't get different font sizes and things like that, but still readable. And writing Markdown is a beneficial skill in and of itself. So, I'm just pointing this out because I think, we're definitely going to cover some Markdown in the last week of class because it is very helpful for note-taking and things like that. So, all right, so let's actually start going through this slide deck. I kind of gave a lead into our premium prep documentations. So we're going to talk about prep goals, the goals of this course, and our expectations for the technical interview. There's more materials on those expectations. I'll try to keep that pretty brief. We'll talk about the materials themselves a little bit more. We'll talk briefly about the study halls and mentoring sessions. We're very heavy on mentoring. Our team is the team that mentors students toward the DSI. We're the people here who are working to get you ready for not only passing the technical interview, but ready for day one of the DSI. So after this, which is our premium prep, there's also a pre-course that you have to complete before you start the DSI. And I'll talk about that when we get further along in the course, or maybe I'll just point at it and say, hey, this exists. You don't need to do this right now. Wait until after you pass the technical interview. That's kind of the TLDR on that. I'll talk a little bit more about the technical interview. And this is really important. We're going to talk about mindset for approaching these materials. What is the mindset of a developer, programmer, designer? What is the mindset of a data scientist? This kind of thing. We're going to talk about this a lot through the course, both from a software kind of a software engineering perspective, which includes a lot of workflow, a lot of how do you see a problem, how do you pick it apart, and we'll also talk about what a data scientist does, right? Like, what do they do? How do they think about what they do? And how can you kind of incorporate those mindsets? These are some technologies, some initial technologies for you to learn. There's our learning software, Learn, which I pointed out. We'll look at that a little bit more. Replit, which is a kind of a browser-based code editor that if you're very, very new to coding, you're probably not going to code on your local machine. You're probably going to code in the browser. And then Google Colabs, which kind of serves, for us right now, serves a similar purpose. And we'll get to that in a second. And I think we're going to start off talking about Slack etiquette, and then we're going to finish off talking about Slack etiquette. Because there are some important things to realize about being in a course that exists on Slack. That exists on Slack and is served through an environment like Zoom, right? So there's kind of a general understanding of how to be in this space, how we want to interact, which needs to be both professional and respectful, of course, but also we don't want to steal people's ability to learn, right? So I'll talk about that a little bit. Our team is me, Lance Bardo, Remy Arata, Devin Dijon, and Clark Walker. Clark is the Python instructor for this course. He just raised his hand. And then our team lead is David Coleman. he generally doesn't serve a technical role. The technologists here are me, Lance, Remy, Devin, and Clark. So we're all the people who perform mentoring. If you have questions more in the admin of things, things like, well, let's say this course isn't for you, you figure that out in the first week, first couple weeks, or you have kind of a strong, let's just say you're like, no, I don't want to do this. You would contact David to say, hey, can I get a refund for this course? And in general, we're pretty we're easy on the refunds, right? It's like, well, you don't want to do this. We want the best for you. Feel free to exit the course. That's something that we don't take a hard line on. And I'll talk a little bit more about what that means from our perspectives in a little bit. So let's see, the premium prep docs, kind of already talked about all of this, right? So we host all of this on GitHub. All of our materials for this course. We host these on GitHub because GitHub is a primary technology for the spaces that you're going to be working in. If it's not GitHub, it's going to be some other system that's like GitHub that's probably using Git under the hood, okay? And we want to serve these things through here. We ask that you set up a GitHub account. That's on the assignments for today. Set up a GitHub account, follow me, follow Clark, and with that, we'll touch on some concepts in Git as we go forward. We probably won't ask you to do anything much with Git, but you will need a GitHub account. And the sooner you start working with Git, the better that's going to be for you in the long run in terms of your workflow. So that's something we have some tutorials on Learn in Git as well. So definitely watch those when you get the chance. Okay, let's talk just a bit about lecture etiquette, and we'll get back to this again. We prefer you have your camera on. What we notice is people are more engaged, and when you're seen, you tend to see, and then I think that's our experience. This engagement leads to, well, if we challenge you with a coding problem or a stats problem, you work on it. You're engaged in the class. You post your solution in the Slack thread, and right, this is the thing. We're all here together. We're all working toward the same goal, which is getting all of you ready for the technical interview and ultimately for day one of the DSI. Please be appropriately dressed. This may seem like the kind of thing I don't have to say. I have to say it from experience. People will come in and they'll, have their shirt off, or I don't know. It's funny, and also don't do that, please. So we put kind of a time box on questions. What we ask is that you ask questions in the thread. Okay, so don't come off mute to ask questions until we say at the end of class, feel free to come off mute. We will say that. We tend to stay on 5 to 15 minutes after class to answer questions. But because we record these in real time, and it's so much easier for us to just take them and put them directly to YouTube. If you come off mute and it gets recorded, we actually have to go edit that out. So if, for our sakes, don't come off mute until we say, please come off mute if you have questions. Also, there will be certain points where we answer questions. We'll usually time box that to 5 minutes, or after a specific concept, right? Like, let's talk about standard deviation and Bessel's correction or something like that. And I go through that and I'm like, cool, are there any questions about this? And then if I see there are questions in the Slack, I'll go through them one by one. So even if I'm being verbal, we're still engaged in dialogue because you're in Slack and I'm reading you in real time and responding in real time. So that's kind of our the way the social construct works here. And at the end of class, again, we tend to stop recording and we say, if you have any questions, come off mute and we'll work on them then. Okay. So speaking of lecture recordings, these are all hosted on our YouTube channel. And you know what? Let me just find this playlist, and I'll fix the playlist in a little bit. Let's look over here. Is it this one? Yes. Okay. So I'll put this in the thread right now, and I will update the link in our README in a little bit. Okay. Oh, it's here. All right. Again, privacy, anonymity. Don't say your name. Well, don't come off mute. that's really what it comes down to. And if we say any of your names, if we have a slip like that and we don't notice it, DM the instructor, DM me or DM Clark, and say, hey, I noticed that you said this thing, and then we'll go back and edit it out. Okay. So what is this cohort about? What is this class about? We want to get all of you to a baseline skill level to pass the technical interview. Now, there's a lot going on here. Diverse students. Everyone's coming from a different background. I don't doubt that there are a couple people in here who have programmed in multiple languages, who maybe are coming from software developer backgrounds and are really solid coders. And I don't doubt that there are people in here who come from very, very strong quantitative backgrounds. Maybe they have math degrees, a higher level math degree. There are people coming from analysis backgrounds, right? There's people coming from, somebody has a master's in English, right? There is nobody who is more predisposed. This is our perspective. Nobody is more predisposed than anybody else to becoming ready for the Galvanize DSI. Okay, what we want is to get you to a level of expressing statistical concepts in code that is sufficient. Now, notice I say is sufficient, right? If you are way, way above that level, that's great. Our goal is not necessarily to present the course to you at your skill level, right? Our goal for this course is to ramp everybody in to the DSI. If you are really above that skill level, reach out to me and I will curate materials for you to work on. I'll give you things that will be challenging, right? So if you are a person who feels not challenged by the materials we cover, reach out to me, okay? And I will give you challenging materials. Okay, so with that said, so I explained diverse students, baseline skill level, and we are working to pass the technical interview. Not only that, but I would say 80% of the materials we cover here are directly geared toward the technical interview, which is not incredibly easy. I'll say it like that. It's not incredibly difficult once you have a solid coding foundation and you can break statistical concepts down in code. But up until that point, it is very challenging, okay? And we need you to pass that to be able to gauge your readiness for the DSI. There isn't significant difference between our materials in premium prep and the materials in basic prep. In fact, many of you, I'm sure, have been in basic prep and have been working on materials there. Today, I imported your progress into our premium prep cohort. You should expect to see that in there, okay? We do this because, this course is really about giving y'all structure and giving you a space to, get your questions answered and to have that classroom experience. I know for myself, I have I'm pretty good at self-studying, but not on everything, right? There are things that I have to be in a class, and it really helps me to be in a class with other people. So, that's just to say that, we parallel our materials between what's publicly available and what's available in this course. we want you to work in the specific Learn cohort. So if you have been working in basic prep, there's going to be a drop-down menu in Learn. And let me just open something up for that. I have a ton of things in my drop-down menu because I'm enrolled in a ton of courses on Learn. You're probably going to have two things, right? You're going to have basic prep, and you're going to have this cohort, which is Data Science Premium Prep, March 1st to April 3rd. I'm going to just try to be conscious that you're working in here, okay? I know that that's not, it's easy to kind of miss this and work in the basic prep and not work in here. That's not too big of a deal, honestly, because I will regularly import your progress. We ask this because we pay attention to your progress, right? We're going to look at how far you've come in certain amounts of time. And once you get to a certain level of completion, somebody from our team, probably me or Remy, is going to reach out to you and say, hey, it seems like you're ready to take the technical interview. Meet up with me for 15 minutes. We'll talk about what to prepare, and then we'll schedule that on a calendar and meet up and gauge your readiness for the technical interview, and then just say, hey, schedule your technical interview for a week out or 2 weeks out or something like that. We won't reach out to everybody because honestly, we tend to be fairly overwhelmed, especially as we get closer to the DSI start dates. But we're going to do our best to be as available as we can. So please take advantage of that. That's why we're here, right? We're here for you to get in touch, to clear concepts up, to ask questions about not only the DSI, but how to go about studying for the DSI. Let's see. This is important. You should interview as soon as you're ready. And I know a lot of people in these spaces, and me included, tend to be completionist, right? Like, I need to finish everything. I need to finish everything before I interview. That's not true, okay? We want you to interview as soon as you're ready. And part of that is we want to get this out of the, we want to get the technical interview out of the way. And we want you to get into more interesting materials than these foundational ones. Not that these aren't interesting, but there is really, really, really cool stuff that we can point you at. Let's say that you have a specific domain of interest, like image processing or financial analysis, and you're like, this is what I want to get into. This is why I'm looking at the DSI. I can say, okay, well, there's this book that I think is really good, or here's this GitHub repository, and you should work through it, code through it. And we can start talking about your capstones and how to build your foundations for, subdomains. That's something we really enjoy doing, something I really enjoy doing especially. And we're not going to recommend that you do any of that until you pass your technical interview. So you don't have to blow your interview out of the water. Again, we don't care about that. We just care if you pass. And that's what we're trying to gauge, right? So interview as soon as you're ready. Try not to interview if you know you're not ready. That's kind of the converse of that. And again, I just want to repeat this. If you are an advanced student, please understand that we are teaching to a more beginner to low intermediate level in Python coding, right? There are a lot of Python things that we won't be doing, such as, comprehensions. We'll do a little bit, right? If you know what a comprehension is, you're probably a fairly advanced student. And I'm not saying you shouldn't take this course. I'm saying, understand that we are catering to many levels of skill coming into this. And so we just need to get people to that baseline again. And if you want more challenging things, reach out to me. I can get you those things. All right. Expectations for the course. Work toward completion of the challenges in the Learn materials. So what do I mean by that? I'll just open up a lesson here. If I'm looking at Introduction to Python. Let's do Python basics. What I mean by a challenge is, let's say in common data types, right? There's all this reading material. And if you get down to the bottom here, what will the following code output? Well, what's the type of -7? It's going to be one of these things. And, many of you might not know what these things are yet. You will soon. But, I'm going to select the correct answer. Maybe I'll start off, I'm going to select an incorrect answer. And if I check answer, it's going to say, hey, you got that wrong. And then I'm like, okay, well, maybe it's this one. And it'll say correct, and it'll give an explanation. So this is one type of challenge. We also have coding challenges. There's a coding challenge in this lesson, your first function. This talks about functions, and there's some lecture video in there as well. And this is actually an environment where you can put code. I don't necessarily suggest that you write your code in here. You can write your code. You can write code in here. I'm going to suggest you write code in a different space, such as Replit, or if you have a local text editor, and then paste your code into this space. But what happens in here is we run your code against a series of unit tests, and you have to pass all the unit tests in order for that code to be accepted and for you to complete that challenge. So just as an example, I'll do this really quick. So this says define a function called mod times 6. I'll try to make this a little bit bigger so that you can all hopefully see it a little bit better. So mod 5 times 6 is the name of the function. It should take a number as an argument. So it's going to take some number as an argument. And it should perform the modulo by 5 operation. Okay, so num modulo 5. It's okay if you don't know what this means yet. I'm just showing how this works. Perform the modulo by 5, multiply the result of that by 6, and then return that result. Okay, so I think this will work, but I want to show you what happens when it doesn't work. So I'm going to just multiply this by 5 instead of by 6, right? So this, we would assume that this shouldn't work. Hopefully it actually doesn't work, because if it does work, then there's something wrong on our end. So I click Run Tests, and notice this says I failed the test. I'm going to say this right now, and I know Clark is going to repeat this a ton. Failing a test is a good thing, right? Failing a test is a very good thing, because we get to see what's wrong, and we get to investigate what's wrong, and we get some kind of error that we can interpret, right? So, run your code often. Look at your errors, right? That is going to be very beneficial to your learning process. In fact, there's a whole framework of development, a whole paradigm in development called test-driven development, where the first thing you try to do is you try to fail your tests. And if you can't fail a test before you write your code, well, then there's something wrong, right? And then you write minimum amounts of code in order to incrementally pass your tests. So this is just, you get a little bit of a view in to the kinds of errors that Python is going to give you. Errors are your friends. We're going to repeat that a whole lot. I know it's a little counterintuitive if you're not coming from a developer background, but errors are very beneficial. They're very good. It's okay to fail tests. It's good to fail tests. Okay, so hopefully I'm hammering that in enough. Notice that we have this assertion error, 5 is not equal to 6. Okay, well, then, let's say I go back and I investigate, and I'm like, oh, I missed this in the description. I'm supposed to multiply by 6, not 5. So I'll go ahead and run this test again, and I'm assuming I'll actually pass it this time. And notice what happens when I pass it. It says ran a test in this amount of time, and okay is what happens, right? It's not rewarding us too much by saying, oh my God, you're amazing. It's saying, okay, it's cool. And then we'll usually have some kind of code explanation here as well. Okay. So let's get back to this slide. Yeah, so that's those are the types of challenges, a couple of the types of challenges in the Learn materials. We expect you to work on those. We also expect you to attend lecture if you can. If you can't attend lecture, we do have recordings. Every round we have, especially people on the East Coast who, have a hard time making a class that starts at 9 p.m. and goes to 11. And so they'll watch the lecture the next day and work through the homeworks and everything and reach out to us on Slack during the day, during their daytime, in order to get kind of the real-time help that we provide. We're going to give a couple homework challenges as we go through. There's also a weekly challenge that, feel free to try to solve. Sometimes those are very difficult. But we'll post those things. They'll either be listed in the actual daily schedule, or we'll post them in Slack as like a @here, go try to solve this thing, or @here, what is the probability of this event occurring, and we'll give you some problem to just answer in Slack. The other thing we expect you to do is, in general, while you're working on materials, right, in your everyday, while you're studying, while you're doing stuff on Learn, if you're stuck on something for 10 minutes, maybe 20 minutes, ask, right? Post in Slack and, post a well-formed question, something that's like, here's the link to this challenge I'm working on. It's challenge 3. Here's what my error is, right? You can paste in your error. You can paste in what you've done so far. And with that, you're probably going to get an answer from one of your peers before you get an answer from someone on our team. And we do that a little purposefully. We actually don't answer right away when people post in Slack because, in general, we want y'all to help each other, right? That's where we're coming from on this. And, if we see it's been up there for half an hour or something, we'll chime in and we'll say, hey, did you think about this? Now, if you are helping somebody, and we definitely encourage you to help people, don't just give them the answer. Use a questioning approach, use the Socratic method, give them hints or something like that, but don't take their opportunity to learn away from them. That's sometimes how we look at that, right? When you just give somebody the answer, it's like they didn't get to have their own struggle to get there. They don't get to own it themselves. So I would just, encourage you to not post answers in general. And if you do help somebody, help them through asking questions that lead them to an answer. Also, I think somebody's mic is on. If everyone can just check really quick and make sure you're muted. It's easy to be unmuted when you join. We have it set to mute you by default when you join the channel, but for me to mute you, it's actually tricky. I have to stop screen sharing, go and mute you, and then screen share again. So just pay attention to that. If I hear something where it sounds like somebody's, where I can hear something through someone's mic, I'll just say something, and if you all could just take a quick look and make sure it's not you. And probably the most important expectation here, I think, is you need to practice. You can't just, if you're new to all of this, you can't just attend lecture and expect to get to a point of being able to pass the technical interview unless you practice a lot. And the way that I compare this often is like, oh, well, you want to paint like Bob Ross, let's say, and you go and you watch a Bob Ross instructional series and every episode of Bob Ross, and you never paint. That doesn't make you a painter, right? You have to paint. You have to be the person writing code. You have to be banging your head against problems. That's very real, okay? Coding is a creative endeavor. And much more, like you'll realize this more and more as you go. You're going to see a problem, you're going to have to break that problem down and come up with one of many, many solutions to solving it. And it's not that there's a better solution and a worse solution in every case. Sometimes there are equally reasonable solutions. Maybe there are some more optimal solutions. But in all cases, you are creating that. Or you're finding a version of a solution that works for your problem. But either way, that takes practice. Okay, so that's something to be conscious of, that you should code every day. Just code at least a little bit every day. And to be ready for the DSI, you should be coding every day. Why do I say that? It's because in the DSI, you're going to be, let's say, given an algorithm, and you have to code that algorithm. You're going to be given some materials in very terse language at times, and they're going to say, okay, well, code this up, and here's some data. Apply your code to this data, and you're not just going to be able to Google the answer in most cases. You're not going to be able to just take something that's already built and apply it. You're going to have to make it yourself. And that's part of the joy of all this, is learning how to solve problems that are very abstract and kind of mind-blowing at times. So I already talked about the materials a bit. Learn is our learning management system. We kind of looked at that. I'm just going to point you at the relevant sections. So hopefully this is actually, this is the right cohort. We've got this initialized and onboarding section. I'm assuming most of you have gone through this, because of the welcome email that was sent out in the last few days. And then there's this welcome to data science prep section. I think if you're like me, then you probably just skip over this and try to find the first materials that you can start writing code or learning the statistical concepts. But I just want to point something out in here. Under expectations, we have this lesson called Expected Skills for the Technical Interview. It's exactly what it sounds like. There is a playlist embedded in here that has 10 videos in it that are directly geared toward the technical interview. There's a list of the kinds of things that an extensive list of the kinds of things we might ask you about. What basic statistics concepts do you need to know? What probability concepts do we expect you to know? How we structure this in general, right? There's kind of a, first section, a second section to the technical interview. And we want you to know, with some degree of depth, these distributions, Bernoulli, binomial, Poisson. There should also be geometric in here, which I'll fix that in a little bit. And we want, to some degree, you to know the exponential and normal distributions fairly well as well. So there's a lot in here to look at in this expectations section, especially in this unit, in this section, Welcome to Data Science Prep. Then we have Intro to Python, we have Intermediate Python, and we have Intro to Stats. So the way that we structure this course between Clark and I, we get you to a level of Python where you can be dangerous, right? That's the first part of this. And then a lot of things start moving more towards stats. Meanwhile, at that stage, we're going to be jumping back and forth between Python and stats. So we try to link to the specific lessons, the specific units. This being a unit, Python Basics is a unit full of lessons, right? We try to link you to these directly from the Readme on Learn, the daily schedule on Learn. So if you keep that in mind, then you shouldn't need to spend too much time searching for what the homework is for that given day, the homework for the next class. We should link you directly to the unit, like Python Basics, and sometime around when we get to lists, I think we get through list iteration. That's when we start on the stats materials. And where is that? It's here. We start in on basic stats, and homework will, start moving more towards stats. So the first part of the course is heavier on Python. The second part of the course is much heavier on stats. I think in the last week and a half, I think I teach almost every class in the last week and a half. And for the first week, it'll mostly be Clark. Okay. So, a couple more things in here. Beyond intro to stats, well, what we cover for the technical interview only goes through intro to stats, okay? But there are more sections down here. One of them is setting up your development environment. And what we mean by that is having the technology on your local computer that you need to write code in a way that will be effective for the DSI. This whole section is about that. Notice there's this GitHub section. There's a section on Unix, Linux, right? There's environment setup. In environment setup, notice we have setup for Ubuntu, which is a flavor of Linux. We have Mac, and we have Windows 10. A lot of you are probably on Windows machines, and that's fine for this course. When you get into the DSI, you'll need to be using a Linux machine or a Mac. And, it's not a huge learning curve to go from Windows to Linux. That's not a huge learning curve at all. It's even a lower learning curve to get into a Mac. It's just Macs tend to be more expensive, and there's a lot more proprietary stuff in there. But as we get closer to the start date of your DSI, the DSI that you're going to attend, we can help you set up for set up on a Linux machine if you're interested in that. Otherwise, you'll likely most people will opt to use a Mac for the DSI. All right, and then the other sections, we've got this extra practice problem section. This is just a bunch of miscellaneous problems. They're fairly categorized, right? Like if you want to work more on list manipulation and methods, there's a bunch of list problems here. We also have this section, weekly challenge problems. Every week we put out a challenge problem, and we post them here. So we'll post in Slack when these come out. I think they come out on Mondays, and we post solutions on Fridays. Correct me if I'm wrong, Clark, on that. That's how I think that runs. And then, okay. And then we'll post materials, the embedded video to the solution in this weekly challenge problem section or unit. And then in further studies, notice we say very clearly this is not required for the technical interview. This stuff is required for day one of the DSI. So it turns out that this thing that I mentioned before, pre-course, that you have to complete before the DSI starts, all of these materials are also in the pre-course. Pre-course just has a little bit more, a very little bit more, but not much more. So let's just notice what's in here. There's some object-oriented programming concepts, pandas, NumPy. Those are both Python libraries. There's some calculus, not very extensive calculus, but the calculus that we need you to know. There's a lot of linear algebra. Turns out that linear algebra is crucial in machine learning. If you've never done linear algebra, don't worry, it's not that hard. And if you need supplemental materials when you get this far, reach out to me. I have a couple of really good resources that I can share with you. And then more advanced stats and probability, and then SQL, which is a database query language that you're expected to know. As a data scientist, you're expected to know SQL in general. You don't need to know a lot before the DSI starts, but it's good to know a little bit, and that's why we have it here. Okay. So, in terms of the materials for this course, we have slide decks, and this is a slide deck, and you may not be able to see this very well, but this is in a directory called slides. And maybe I can just, we can look at it this way. So this is the landing page for our GitHub repository. We have two directories here, slides. These are all our lecture slides. They're numbered. They're slightly out of order. I'm going to reorder them. We just moved a couple things around last time. We do that pretty much every time we do move materials around and edit them. This SRC directory, so SRC is source. We've got two subdirectories, Python and stats. Clark, when he teaches, he's going to be putting his code in this Python directory. When I teach, I put mine in stats. There's further subdirectories in mine. Clark does not use further subdirectories. He's just going to have a list of files for each day that he teaches. So, this is topical. So it doesn't directly parallel this. Well, it does parallel the slides, but it parallels it by topic because, multiple slide decks might influence the same code base. Okay. We do have bugs in our materials. That's very normal. We are constantly making stuff. And if you find a bug, especially grammar errors, message me, message Lance Bardo. We'll just fix it on the fly. We do our best to copy edit everything, but we're all technologists and we get grammar pretty wrong sometimes. So, if you're better at grammar, please tell us. Please be like, you can't do this, and have it be understandable, and we'll fix it pretty quickly. And that goes for any of our materials, right? Any of the stuff on Learn, any of the stuff in the GitHub repositories. If there's something inaccurate, definitely tell us. If there's something grammatically incorrect, misspellings, anything like that, please tell us. Format of the lectures, 2 hours Monday through Thursday. And then we have 2 hours on Saturday, right, which happens in the early afternoon, depending on your time zone. We don't review homework in the lecture, okay? And the reasoning for this is the homework checks itself, right? The other thing is, if you want help, we've got our community in Slack, and you also have us as mentors. You can reach out to us at any time directly if you don't want to post something in Slack. If you feel like, oh, this is really elementary and I feel embarrassed for asking it. First off, don't feel embarrassed about asking things that you think are elementary. Please just ask. If you don't feel comfortable asking, that's also understandable. Reach out to one of us directly, and we're happy to answer. There are no dumb questions. This is a big space. For many of you, this is very new material. So, I definitely encourage you, ask anything that you feel unsure about, even if it seems obvious, even if it seems like it should be obvious. Should be obvious is just not the case. There are things here that other people might understand quickly because they have prior experience. But if you don't understand it, please ask. In general, the way that these lectures will work is we'll teach a concept for 5 to 15 minutes, and then we will have a challenge, some kind of breakout, or maybe a couple breakouts. Those will usually be between 2 minutes and 7 minutes long, usually hovering right around 4 minutes. And we kind of just do that over and over again. Part of this is like, we want you to code a lot, and we want you to code a lot in class. So we're going to give you a lot of challenges. I teach a couple classes, especially later on, that are much more concept heavy. And some of that will be you watching me code, essentially you watching me code. And I'll stop and I'll ask you questions about what I'm coding. I'll say, well, this is what I've done so far. What should I do next? And, or I'll say, how would you interpret these results that we're seeing from this thing that I made? And part of the reason I have a couple classes like that is we don't need you to code at that level at that point, but we do need you to understand the concepts at that point. And that's why those lectures exist. Also, a couple of those lectures are really fun, especially the kind of intro to machine learning class where, a lot of this kind of the process of writing code and incorporating statistical concepts congeals around actually employing a machine learning algorithm on some data and seeing what that looks like, and moving from a procedural paradigm to a machine learning paradigm, which is what you'll be doing prior to and during the DSI. If you ask a question in Slack that we don't have time to answer in there, or if it's kind of out of the scope of what the course is about, we'll either address the question at the end of class, or I'll, in my case, I'll often say, let's talk about that. Let's meet one-on-one, in a Google meeting, or, at some point tomorrow, or, if there's time still, if it's, if class just ended, we can maybe meet one-on-one. Part of this is like, I'm a big questioner of things, and sometimes I ask, very left field questions because they help me understand something. That works sometimes, but sometimes you get this kind of, you get this wormhole, right? Where, 30 minutes have passed, right? And we just talked about some concept that you don't need to know right now for 30 minutes. There's nothing wrong with that, except that it takes up everyone's time. So I try to do that outside of class, and unless it's something that we can apply in real time in class. Study halls happen 3 times a week. That happens 3 to 5 Pacific time. We post in the Slack channels when those go live. It's usually between 3 and 5 or 3 and 4:30, something like that, Pacific time. We provide these in part to better support people on the East Coast because, the class is late for them. And we don't have anything else right now that we can use to better support them, except for mentoring and study halls. It's just a great place to ask questions. So you'll ask questions in Slack. Generally, Clark is leading these, and he'll address those questions in real time in the YouTube stream. This is a good reason to subscribe to our channel on YouTube, right? Because then you'll get notified when the stream goes live. If we have to cancel, and sometimes we do, occasionally there are technical issues, but sometimes there are other things that take priority on our team, we'll try to cancel, with about an hour lead time, something like that. Sometimes if it's a technical issue, I think this happened last week, we had to postpone by 30 minutes. So that kind of thing can lead to a cancellation as well. But in general, Monday, Wednesday, Friday, 3 to 5 p.m. Pacific time for study halls. So we're big on mentoring. The team members to reach out to, that's me, Tovio Roberts, Clark Walker, who's your Python instructor, Lance Bardo, Remy Arata, and Devin DeJohn. So that's why we're here, especially for the duration of this cohort, or at least for the first 4 weeks of it. We will be much more available than we will as the next DSI start date approaches, right? So we have, for us, it's kind of work-wise, it's feast or famine. There's a point where we are interviewing a ton, and we are taking care of last-minute things for the start of the next DSI, whether that's pre-course, or heavier mentoring. So mentor early, and use us. We're a resource. And sometimes you don't get something in lecture. Sometimes you don't get something out of the materials. And when you meet with one of us up, one-on-one, we can tailor, your understanding to what you know already, right? So please reach out for mentoring. That's why we're here. So deferring, what we mean by deferring is if you feel like you're behind in this course, let's say you get into the 3rd week and you're like, I have done the first day's homework, reach out to one of us. We can either meet up and try to get you up to speed. That's definitely an option. Or if you want to defer to the next course, life happens, a lot of things come up. We will just add you to the next course. There's no cost for that. The way we see this is it's kind of like a subscription, right? Not a subscription, I'm sorry. It's kind of like a one-time, and then you're in prep until you're not. And the point where you're not in prep anymore is essentially when you start the DSI. So you can defer as many times as you want. I will make the suggestion that if you pass your technical interview, don't defer to the next cohort. Just reach out to me and I'll give you more things to work on. That gets back into this point of supplemental materials. There's a lot of things that I can give you to work on. So if you feel like you're far ahead, reach out to me. If you pass your technical interview, then you don't necessarily need to continue with the premium prep. If you pass the technical interview, reach out to me. I'll say, okay, here, go work through these parts of the ISLR, and start coding these algorithms and see where you get. And if you get stuck, we can sit down and talk about where you're stuck. Or here's some linear algebra stuff if you've never done that before. So, that's how this looks. Yeah, you can stay for as many cycles of premium prep as you need, and that's how we run this course. So in terms of practice materials, there's this thing called Code Wars, and I recommend that everybody, this is actually in the homework, sign up for Code Wars. And you may not be able to do problems on this now, but you will be able to soon. And as soon as you're able, you can use this as a place to do reps. This is like your mental gym, right? You just learned how to do a couple things. You go and you work out on Code Wars. Or there's some other options too. There's HackerRank, LeetCode. There's a few of these. But I like Code Wars the most. I won't talk about why at the moment, but this is a great place to practice if you feel like you're very ahead and you want to get your coding chops up. One thing about this, the way that difficulty works on here, the difficulty 8 is the easiest. The difficulty 1 is the hardest. I would not expect anyone in this course at this moment to do anything harder than an 8, okay? Unless you have a strong coding background. Generally, we say that the level of the technical interview is kind of at a 5 or a 6, although it's not actually that comparable in some ways, right? Because it's a lot of statistical concepts and probability concepts as well. So, another thing that's in the homework is please apply for the DSI. The reason to do this is that gets you access to a specific enrollment advisor. So, there are questions that our team is not great at answering because we're not necessarily on the bureaucratic side of things. We are on the educational side. We're here to teach you. If you have a question about what is it? I can't remember the name of it. See, this is the thing. It's where you don't pay for the course. I should know what this is called. Where you don't pay for the course until you land a job. That thing. I'm sorry, I should look this up. I feel a little embarrassed about it. There's a phrase for it. If I knew that phrase, I could say, hey, go talk to an enrollment advisor about that thing. ISA, thank you. Income share agreement. Yeah. So there are income share agreements. Obviously, I don't know very much about this because I can't remember what it's called. So asking us questions about that is not the best course of action for you. The better thing to do is to just do the very quick application form, the admissions form for the DSI. You don't need to do much in there. It's some very basic information that gets you in touch with a specific enrollment advisor who can answer the questions that I obviously can't. I already talked to some degree about the technical interview. We'll get into this a lot more as the course goes on. So I don't want to spend too much time on this. I do want to, again, point you at the technical interview YouTube playlist that has something like 10 videos. The thing that I often say is if you can go watch that playlist and code all those things if prompted, you're likely going to pass the technical interview. So that exists. It's embedded in the expectations unit for the technical interview on Learn. So that's something that is another piece of material. The approach that I take in those videos is the approach that we're going to be taking throughout this course as well, especially for the distributions and for other types of problems. So, I'm not saying you need to go watch this. It's more like if you want to gauge where you're at. If you could code all those things from scratch, then you are almost certainly going to pass the technical interview. The interview is 45 minutes long. So if you think about it, that's actually not that much time. That's part of our, our mandate to not necessarily write the best code, but write code that you can write quickly. This course is a little bit about that. We won't always do the best solutions, but we'll do solutions that are understandable and that you can write quickly. And that's what you're going to be doing in the technical interview. We need you to take algorithmic concepts, commit code for them, and analyze the outputs of functions that you write. There's a coding challenge. So when you do your admissions, when you do your application, you'll gain access to the coding challenge. You have to pass the coding challenge before you can schedule a technical interview. So you don't have to do it at that time, right? But you do have to do it before you can schedule. So I just want to mention that because it's here. Now, I think maybe this is implicit in everything I've been saying. We are not trying to stop you from going into the DSI. We are not gatekeepers. We're trying to get you there. That's our role. That's why we're here. So we're kind of facilitators or shepherds. We're going to do our best to meet you where you're at and help you get to the coding and quantitative levels to be able to pass the technical interview. Maybe this goes without saying. If you're a beginner, you're a beginner. You don't know yet the things that you don't know, and that's totally okay. Some people will take, I think I said this before, some people take a couple weeks and they're ready to pass the interview. I know people who study for 9 months. I know people who've studied for over a year. I know more of what we see is people study for about a month and some change, and they're ready. But this isn't going to be, it's okay to have all that prep time to get into the DSI. That is absolutely fine, and we're here for that. There is frustration that comes along with this. I think that frustration is good, right? When you're working on things, when you're learning things, you're like, oh gosh, I cannot understand this right now. Well, that's the thing. Right now, you are bending new parts of your brain into doing new things that you've never done before. So if you approach it with that mentality, like, oh, I don't know this yet, that is going to do a lot for you. All of you are capable. All of you are fiercely intelligent. I think all of you can get there, given the practice, given immersion in this material. There's a link here to something called the Beginner's Creed. It's kind of a poetic synthesis of what I just said. This is important also. Everyone's path is different. Maybe that goes without saying. So don't rely on other people's benchmarks. Rely on your own, right? Say, I'm going to get this far. Don't say, this other person got this far. I need to get that far. Otherwise, I'm a failure. No, you can set your own benchmarks and work with us you can work with us to set goals as well. I think we're pretty good at establishing those. Like, okay, well, here, by next week, try to have this concept locked in. If you're looking at a timeline of 5 weeks out to pass the technical interview, well, here's incrementally how we can get there. I'm going to kind of skip over this because it's kind of the same thing. Growth versus fixed mindset. There's written works on this. Essentially, go to the places that challenge you and don't be afraid of that challenge. It'll be frustrating, but that frustration is good. There's also, encourage others, as best you can. I think if we notice, I don't think it's going to happen, but if we notice anybody being like, well, I can't do this and neither can you in the Slack channels, I think we'll be like, hey, everybody has this capacity. So, encourage your peers and as well as encourage yourself. So this is a thing I'm going to just harp on for a second. Thinking critically. I think in our present day, given recent political and other events, I think it's clearer and clearer all the time that we need to think critically as humans, especially as people who call themselves scientists. Whatever kind of science you're doing, you need to think critically. This involves a lot of deconstruction of preconceived notions and noticing of the kinds of biases that you employ in your everyday. If you're a data scientist, you have to do this. You have to be willing at times when 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 your business owner comes to you and says, "Hey, here's all my medical bills. Can you predict how my stocks are going to do in the next couple months?" And you can say, I can't, and nobody can. And you need to be able to look at a problem and say, that's not solvable given what we have. And that involves thinking critically. Involves not being wishful about the outcome. It's about looking at what we have and employing the various methods to engage with those problems, with our current understanding. It means knowing, being able to observe when you're wrong and being able to relinquish when you're wrong. When you say, oh, I thought this worked this way, but I'm not correct about that. And becoming comfortable with being incorrect, which is really hard for a lot of us. I know that used to be very hard for me. And, at this point, I'm like, oh yeah, I'm wrong all the time. But I just want to be able to notice it. I want to be able to see it. I want to be able to put my eyes on it and deconstruct it so that I'm not wrong about the same thing in the future, right? You want to think critically about the problems. You want to use scientific approaches, evidence-based approaches, experimental approaches. You want to be able to ask the right questions, even questions that seem outlandish from out of nowhere, like those questions can be, inspiring for the solution of a problem. Of course, you don't only want to answer out of left field questions. You want to answer, the important questions and work out from there. But this is all part of thinking critically. There's one of my favorite websites ever. It's actually just an article on Wikipedia, the list of cognitive biases. And this is just a massive list of exactly that, of fallacies and cognitive biases. And this is the kind of thing that I just wish so many people would work through this. Like, look at these one by one and see what they're doing. See what we're all inclined to do at various times, right? We're probably aware of a few of these, but when you start studying these kinds of things, it really helps you to see what you might be doing on like a data analysis problem. Like you might feel compelled to interpret data in a certain way that just isn't really what's happening. So I encourage everybody to look through these on your own time. I'll be talking about this kind of thing a little bit here and there throughout the course. Okay. In general, we'll take a 5-minute break, but I'm just going to wrap up this welcome lecture before we have a 5-minute break, and we'll see how much time we have to get into some Python after that. So, Learn, Replit, and Google Colabs. We looked at Learn, right? I showed you how a coding challenge works. There was a multiple choice challenge, right? That I think there's a fair understanding of that. If there are any questions about that, definitely ask. And if you need more of a walkthrough of some of that, we can do that. Now, there's this thing called Replit, REPL-IT. And what this is, for our purposes, this is a kind of a browser-based coding environment. And I'm just going to pull this up and show you how this works. So many of you who are new to coding are probably going to start by using Replit. You're not going to install VS Code this week, maybe not even next week, right? And in fact, it's kind of okay for the duration of this course if you only use Replit, although I'm going to encourage you to start using VS Code, by beginning of the third week, something like that. But even if you only use Replit, that's kind of okay. Let me make this a little bit bigger. So what this is, if I want to make a REPL, I can do this plus button over here. Python, because Python is the language that we're going to be using. It names it Agile Prudent Monitors in this case. It names it automatically, but you can name it as well. And then I create a REPL, and it takes a second to load up. Sometimes it's not the fastest thing in the world, but that's also okay. I can write code in here, right? So print, how about I do this? I'll do name, my name is this, and I'm going to print a message that will output in the terminal. So I'm going to say my name is, and then I'll put my name in there. And what I can do now is hit run. And it outputs to the terminal over here on the right. So this is very straightforward in that sense. You write your code in this, let's say in the simplest version of this, you write your code in main.py, you hit run, and it runs it over here. Pretty straightforward. There's a question, can I use my IDE Spider 4? If you feel good about Spider, definitely use it. But at some point, you are likely going to need to use VS Code. The reason I say that is VS Code has some excellent tools for pair coding. There's a strong emphasis on pair coding in the DSI. So up until that point, feel free to use Spider. That if you feel good about it, definitely use it. I don't prefer VS Code myself. You'll notice that Clark will likely be using Atom, not using VS Code. I prefer Vim, or I prefer Sublime Text, honestly. But I use VS Code because it is kind of the default text editor for the DSI. So just keep that in mind. You will need to use it at some point, but you should feel free to use other coding environments as well, except when you're pair coding, where you should use VS Code. REPL, read, evaluate, print, loop is what that stands for. And that said, let me show you a local version of a REPL, the Python interpreter, which, let me make this a little bit bigger. So this is a terminal. Depending on what operating system you use, you may not be familiar with your terminal, or you might be. Or maybe you have a different kind of terminal, like Windows machines don't necessarily have a Z shell or a bash shell. This is bash. So I just ran this thing called IPython. Sorry, let me make this a little bit bigger. I guess it's probably pretty small. I'm using IPython here. This is another coding environment that is a lot like REPL. So I can actually paste my code in from here into IPython, and notice I get some output right here. The output of this little snippet of code that I just wrote. If you have Anaconda installed, you can use this, but if you don't worry about it. But this is another example of a type of REPL. Okay, this is kind of the classic version of a REPL. All right, so the other thing I wanted to show you really quick, as kind of an intro coding environment, right? Because I think most of you who are new to coding will probably use REPL, and that's great. There's nothing wrong with that. The other environment you might use is called, I call it Jupyter Notebooks, but Google has a version of this that is browser-based. Jupyter Notebooks are generally browser-based, but Google has a version of this that they host, and it's very powerful, called Google Colabs. So oops. So in Google Colabs, you can create something called a Jupyter Notebook, essentially, or a Google Colab. I'm sorry, Clark, did you have something?
Didn't.
Oh, okay. Sorry, I think somebody's mic came off for a second. So the way that this works is a little different from REPL, but is, it is just a coding environment. So in this case, I put into this code cell those same snippets of code. And if I hit play here, it takes a second to run the first time. And I get some output. And I can also make a new cell and write more code down here. I'm gonna output the result of name in this code cell. And notice I get some output. It says my name because that's what's in the variable name. The other thing I can do in here is I can make a text cell that is not a code cell where I can put text. So this is kind of cool. I can actually put mathematical formula in here. I don't know, probability of A given B equals, and notice I'm getting output over here on the right. I'll just finish this out. Probability B given A multiplied by the probability of A all over the probability of B. So notice over here I get nice mathematical output. So this is kind of a great benefit of this kind of environment, which is a Jupyter Notebook or Google Colab, depending on who you're talking with. And you can make notes that are, presentable, very presentable. And you can have them alongside code. A lot of research actually gets written and formulated within Jupyter Notebooks, because you can dump it down to HTML, or you can dump it down to Markdown or some other or a PDF, and you get this nice mathematical formulation really easily that way. Yeah, it's this is LaTeX, but this is a special form of LaTeX. This math code here. This is called MathJax, which I link to in the helpful link section in the daily schedule. But here, this is MathJax, which is a sort of subset of LaTeX, which is a mathematical, let's call it a formatting language. Okay, so, let's leave that there and get back over to the slides really quick. And I think we've got one more slide. Yeah, and that's just to repeat Slack etiquette. Answer questions using the Socratic method. Lead people. Don't give them the answers. There are times where, maybe it is appropriate to give somebody an answer, but in general, try to lead somebody toward the answer so they get the opportunity to own the thing they learn. Keep questions in the threads. That's, if you noticed, a lot of you posted outside the thread, which is fine. I just screen captured that and dropped it into the thread. So that's my solution. And in general, just post in the threads. If you post a unique question, of course, you're going to post that. Sorry, if you are stuck on something in the Learn material, kind of on your own time, not during lecture, and you get stuck on something, you're going to post that in the main channel. And that's how people will see it. And then they can respond in the thread under your post. So that just makes everything way easier to organize. People can scroll back up and reference things. So, yeah. Let's does anybody have any questions about any of what we covered? I know that I tried to go for 45 minutes. It usually takes about this long. Do I recommend using Google Colab or Jupyter Notebook for this course? I honestly recommend starting off with REPL, and somewhere around the end of the second week, beginning of the third week, try to get a local Python environment installed on your computer. That's what I recommend, and that way you're used to the coding environment of REPL, and it's an easy transition to VS Code. The thing about Jupyter notebooks is they're amazing, and they can also become a bit of a crutch. There's nothing wrong with having them as your development environment, but we want to put more focus on writing code in a text editor. In fact, almost solely throughout this, there's only going to be one lecture where I code in a Jupyter notebook, I think. Otherwise, both Clark and I think, will solely use text editors and terminal to run code. So that's what I'm going to recommend.
That real quick?
Yeah, please.
Oh, yeah.
Oh, no, that was it. That I finished right when you said.
What environment to choose. And it's kind of dynamic. If you have some experience where you you maybe had some technical background where you've done some coding before, and you have an environment that you're familiar with that you know works for you, use that. That's an easy answer. Like if you did some, you took a programming class a while ago and you're familiar with Jupyter and you know how to use Jupyter, go for it. However, Tovio earlier brought up a good point about VS Code is such an industry standard. It's kind of entrenched and becoming entrenched, which I kind of don't like, but it is. So it's a tool that's worth knowing because you're going to encounter it. VS Code calls itself an IDE. It's a borderline between a text editor and an IDE. It's kind of like a text editor that's become so bloated that you have to call it an IDE at this point. It's a decent editor. I'm being a little hard on it. I don't totally hate it. It's fine. My preference is Atom because that's what I learned on. That's what VS Code is based on. It's the open source editor that VS Code is built off of. And it's just what I've been using forever, and it's what I just love it. It's just like my favorite little thing. So here's sort of the axiom that you can use, and that I would say I would use in terms of if you're going to choose a tool. In general, what we're going to do is we're going to use a simpler tool rather than a more complicated tool that's more powerful, right? IDEs exist for good reasons to be very powerful and help automate the process of writing code. Right now, or at least, where Premium Prep is aimed is for helping you learn how to write the code yourself. If you don't know how to write the code yourself, it's kind of tricky to give somebody a tool that will automate code writing for them, because you're sort of relying more on the tool, and then being able to code outside of that environment kind of breaks down. Or you either get reliant on the IDE itself, or it becomes more a matter of learning that particular IDE than learning programming. So in general, we stick with simple tools where you're writing in a plain text editor and executing your code in a terminal. Replit tends to sort of emulate that model well in the browser. It approximates it well. So that's, if you want an easy place to start, that's what we tend to recommend. VS Code, Colab and Jupyter tend to sort of play just a different rule, and it's a tool that you'll pick up as you go, in my opinion. There are other people who use it as their primary environment. I don't know how that's possible. I couldn't do it myself, but people do, and they love it, and that's fine. If it works for them, who am I to say? So anyways, that's my 2 cents, or 10 cents was kind of longer than I meant.
Cool. Yeah. I echo everything that Clark just said. There's a good question in there. Is it wise to use a partition or VM to run Linux on a Windows machine? Yeah. Yes. I like the approach of allocating a partition. I like having a native install of Linux. That said, you can set up VirtualBox or VMware and run Linux as a guest, right? And that the thing you lose there is some of your computational power, because you get some allocation of RAM, unless you have a large amount of RAM, right? Like let's say you have a 32 or 64 gigs, and you can allocate 16 gigs to your VM, then that's not really, unless you can do that, then you can't really use that Linux machine in the DSI. So in that case, I think it's better to have a partition, right? If you have 16 gigs in your machine, then having a Linux partition is a better way to go, in my opinion. If you have more like 32 to 64 gigs, then a VM should be fine because you can allocate around 16 gigs. Keep in mind that in the DSI, I'm speaking of the DSI specifically here, because for our purposes now, you can use Windows. It's not a problem. But once you're in the DSI, you'll need to be able to run Zoom and your related applications for your development environment while pair coding, right? And so there is a bit of overhead there. And so we tend to say, well, your minimum specs for, let's say, a MacBook Pro is 16 gigs of RAM and, a modern processor and 512 gigabytes of hard drive space. That tends to be the bottom line. So if you can accomplish that in your VM, that is doable. That's doable. I would still, try to urge you to have a native install, whether partitioned or not. Yeah, totally. The statement partition is also helpful psychologically since it'll be really bare bones and you won't have to worry about distractions as much. I completely agree with that. My tendency is to literally have a separate computer that I do other stuff on, right? And not, to try not to have them both be, I'm going to watch Hulu and I'm also going to run, this machine learning algorithm in the background. I prefer to keep those separate. It keeps my focus really good. Cool. Are there any other questions? I'll just give this about 10 seconds. Please ask any questions if you have them. And if there aren't any, then we'll move forward. Also, we're going to forego the break today, but in general, we'll have between a 5 and 10 minute break at the middle of class, around the middle of class, every class, just so you know. We won't just slog. This class is the slog. Apologies for that. It's a lot of talking, and in general, we try to mix that up a little bit. Okay, so let's look at this first slide deck. I'm going to jump around a little bit in this. This is just kind of an intro to Python. So, what is Python? Python's an interpreted language. What does that mean? What are some resources in regards to Python? What is a text editor? We've been talking about text editors. There was, a great question. What is an IDE? Well, we should probably differentiate between an IDE and a text editor in, clear terms. There's a general sentiment of how to program, and then if we can get this far, because we'll reiterate some of this in the next course, then we'll talk about comments and simple operators in Python. So generally, Python is this general purpose language. You can kind of do everything with it. and it's pretty amazing. It's fairly performant. It tends to be a more performant language than Java in a lot of cases, depending on how your code is written, of course, and how it's deployed. It's maybe not as performant as something like C, but it definitely occupies a space where you can do tons of different things with it, from game programming, app development. You can easily run Django and whip up like a massive multi-user site that is going to be very functional. You can do that, in hours, depending on your level of skill and what you've done prior. It's a language of robotics. For us, the way that we're going to apply it is as a scientific language, right? There are a lot of scientific libraries for Python. There's data science, where Python is the language of data science, along with R, and you could argue for Scala, and there's a few others, Julia. There are other languages of data science, but by far the most prevalent language is Python. What's great about that is that Python is remarkably friendly. It's a very easy language in a lot of ways. It reads semantically more like spoken language than any other language that I've written, except for maybe Ruby. Ruby is very much like human language, which makes it not as good as Python, in my opinion, because in Ruby you can do things 20 different ways, and in Python, well, you can do things like 5 different ways, and it's a little bit nicer in that way. It's easy to atomize problems with Python. There's also there's really amazing resources like machine learning libraries and scientific computing libraries that incorporate that are very high performance because under the hood there are parts of it written in C and Fortran, and there are ways of deploying it that can be deployed across clusters. One of the main languages of supercomputing is Python. It's because there's a huge scientific community that kind of defaults to Python. They used to R more so and to C, but Python is just so easy that you can be a biologist, right? You can be a research biologist, and you're like, oh, I need to learn a programming language to analyze gene encodings. Well, you're probably gonna learn Python to do that, or R, but you're probably gonna learn Python because it's just easy. It's really nice. Initially, I already said this. Initially, we can think about using REPL to code in, and I'll probably code a little bit today in REPL, a little more than we've already done. Okay, so Python is C. Sorry, there's a good question. Is C++ faster than Python? Yeah, generally. I mean, the design of an algorithm is important in determining the time complexity of something, right? How well it performs. But in general, C is much closer to the metal, you could say. So when you're thinking about Python, we're thinking of something as being interpreted and higher level. So maybe I'll draw a little bit of this, how I'm thinking about this, because when we think about certain languages, we think about them being very close to assembly, right? So that could be true of C or C++, where okay, my pen's not working. That's great. One second. All right. That's what happens when you unplug things; they stop working. All right. So when we're thinking about this concept of abstraction, all right, abstraction is how far, for our purposes right now, it's how far away from the actual switches, the ones and zeros that are fundamentally underlying the computer. Well, Python, if we're thinking about it in terms of some kind of hierarchy between, or some distance from the metal, the actual switches, we might see C down here, and we might see C++ as being very close to C. And we might see, this idea of assembly language down here. And we might see a language like Java here. And we might see Python somewhere right around here. And part of this is that these are what we call, we generally call these compiled languages, right? C++ and C. And then Java, this is weird. You don't need to know this, but Java is called precompiled because that's what it is. And then Python is actually interpreted. And what this means is that there's some kind of environment. There's some kind of virtual environment that is running Python. So what if we called this the PVE, even though that's not what it's called, the Python virtual environment? You're going to write some code, let's say in a text editor, right? So here's some code you write, and you're like blah blah blah, print some stuff, and then you throw this into here, and your virtual environment might say, hey, there's an error there, right? Or your virtual environment might say, oh hey, here's some output, here's the output that you requested from this. You kind of do this in real time, and you just go back and you write it again, and you keep incrementing your code toward the solution that you want it to occupy, right? With these compiled languages, what you do, this may not seem entirely different, but in practice, this is fairly different. You write some code, and then you put this into something that translates that code, right? It translates it, but it does not run it, right? So you have some translation, and then you run your code, right? And you run your code kind of on the machine level, right? You run it, it is compiled, it is translated and compiled to run very low to the switches on your machine. In fact, it might even be an assembly, depending on how it's compiled. So you run it, and if you have an error, well, you find out at that point. If you have an error that happens to disrupt, some of the storage on your hard drive, well, then you just displaced a bunch of storage on your hard drive, and you just killed a bunch of data on your hard drive. That's not that hard to do. Well, you might do it unintentionally. Let's say it like that. It's not that easy to do, but you might do it unintentionally. You're likely not going to do that with Python, at least, not until you're a little more dangerous with it. So the process of writing code is different. Your workflow is different. You're going to compile your code, run it in C or C++, and then you look at what it does. One nice thing about an interpreted language is that you immediately see what it does, and that's great. That lets you code way faster, although you do sacrifice some computation time up front. Now, one of the C and C++ are languages of data science, but you encounter that more when you are writing something that needs to be very optimal from scratch. And when you learn things like TensorFlow or PyTorch, the neural net, the libraries that you use to build neural networks, a lot of that is written in C, but you leverage those libraries using Python. You get the performance of C, but you never actually write C. You never even see it. You just write Python for it. If you have to, if you're inventing a new neural network architecture, you're probably going to use something like C, or you're going to use something, another language that's high performance and possibly compiled. You might even write something in assembly if that's the direction you're going. Okay. So the way that we can see this interpreted language concept in real time is right here in Replit, right? You can see right here, if I run this, I get immediate output. And if I change this to, so I have this, we have this kitten that we just got that we haven't named yet, and we call Kitten Chan. And if I do that, my name is Kitten Chan Roberts. Okay, well, that's great. I see the results of this immediately. That's easy to see. I can change this to anything, right? I can change any aspect of my code. Let's say, value 1 is 20 and value 3 is 50. And I can say, val 1 times val 2 equals something. And you don't need to understand how this code works. I'm just pointing out that I can write this very easily and see the output of it immediately. Val 1 and val 3. I didn't do a val 2. Okay, val 2. So I can run this and I get some kind of output. Oh, except I didn't, because I actually got error as output. But that's nice too, because it's interpreted. I immediately get an error and I can solve that error. If you've ever written in a language like C, this process of discovering errors is hard in C. Whereas in Python, you just get an error right away and you can fix it. It means you can run your code a ton. You don't have to compile it constantly and run it. There's a quick question. Let me answer this. Well, I'll answer this at the end of class if you can stick on for just a couple minutes. The question, why are Linux and Mac machines better for the DSI? I can definitely speak to that. Okay. So, we talked about compiled languages. Python documentation, it tends to be really good. So, these links are here. I'll just click out to this really fast. So here are Python docs. And this is the 392 documentation. When you're in the DSI, you're probably going to be using 3.7 something, 3.7.4 probably. So if I go back to this, this is 3.7.10, but that'll work for 3.7.4. Pretty much the entire language is here. And this is a great resource. It may not be your first place where you look for information all the time. And let me just say this, probably what you're going to look for first, right? Let's do Stack Overflow, comprehensions, and I'll say print statements. Combining print statements with list comprehension in Python. Immediately, Stack Overflow has some kind of answer, and not just one, but multiple answers. One thing about being a developer, about being a data scientist, is you learn how to use Google really well, and a lot of the time you go first to Stack Overflow. That's really one of the places. That said, the documentation for Python is really good, and it is definitely worth spending a lot of time getting to know it, because there are going to be things where you can't find an answer to a question easily on Stack Overflow, and you'll go straight to the documentation, or it'll be quicker just to go to the documentation. There's also this idea of a style guide for Python. This is PEP 8. If you're a Python developer, you know PEP 8. You interact with it all the time. And this is just guidelines for writing code. Like, how do you structure it? How many spaces do you use for a tab? 4 spaces is what basically every Python programmer does, except for a couple people who don't, and everybody hates those people. No, that's not true. But people don't like people like convention because it makes the code easier to read. And so if you follow the conventions, and you don't have to follow all of them, I definitely don't. And Clark definitely doesn't. We both have a couple divergent things we do from convention, but we do those for reasons because we've thought about it. In general, if you haven't thought about the reasons for doing something, then follow the convention. If you know the convention in order to violate it, is kind of the way to think about that. Okay. Practice on Code Wars, please. Code Wars is awesome, And yeah, we can definitely meet up one-on-one at some point, or maybe I'll do a supplemental at some point for, where we can all hang out and do some code wars for a bit. Okay, so text editors. Text editors use some kind of standard encoding. Now, why does this matter? Well, how about you open up a Google Doc or Microsoft Word and try writing code in there and watch how it formats things. Watch the quotation marks it uses, and compare that to what we see in something like REPL, where REPL has some basic standard for, let's say, a quotation, right? Double quotes or single quotes are standardized in text editors. Why is that important? Well, if you have a non-standard thing that looks like a quotation mark, Python won't know how to interpret it. So we use text editors in general. You don't want to write code in Microsoft Word. You don't want to write code in a Google Doc. You want to write in a text editor. What we recommend is VS Code for the reasons aforementioned. Ultimately VS Code. But any text editor you use is going to have some kind of, it's going to follow the standard. It should, right? It should follow a UTF-8 standard. If you want to know more about UTF-8, you can look it up here. But really, I just want to say that there is some standard for the characters we use. And because coding involves formal language that has to be structured in a certain way, we need to have a very official form of the characters we use. And for us, that's going to be UTF-8. Again, we use VS Code. And in our installation instructions, you're going to install Anaconda. Ultimately, that's going to create that's going to give you your Python environment. Okay, we won't get into that here. We usually do some kind of installation session or a few of them later in the course. Okay, so how to program. I'm going to teach you this in 5 minutes, all of it. That's not true. I'm just going to kind of give you an overview of how to think about programming. This may seem pedantic or something, but think about the problem. You're given a problem. Think about it. Consider what it means to solve that problem. What does it mean for your program to solve the problem? And then you create a series of steps to have a repeatable operation for solving a problem. Let's think about this. I'm going to think about this in terms of something, a fairly simple algorithm that we ask you. If you're new to programming, we often ask you to just memorize this function. The reason we ask that is that it follows a common pattern. But I'm going to work through this, and again, you don't need to understand how this works exactly, but I want you to understand that there's a series of steps I'm taking to get to a formal repeatable operation. Okay, so let's think about factorial. 5 factorial, right? Well, 5 factorial is going to be 5 times 5 times 4. Oops, sorry, I'm mashing keys over here. Times 3 times 2 times 1, right? That's how we think of 5 factorial. Can we use this same exact procedure to solve, 7 factorial? Well, we can use the same procedure, but we can't use the same exact values. This statement right here is not true. 7 factorial does not equal 5 times 4 times 3 times 2 times 1. So, the way that we might think about doing this is creating a repeatable procedure. And I'm going to wrap this in a function, but I'll talk through this. I'll try to give you a sense of how to think about this. So I'm going to define something called factorial. And my goal for factorial is to solve any factorial problem that can be solved. So the factorial of some number is going to equal that number multiplied by 1 minus that number, multiplied by 1 minus that, multiplied by 1 minus that, and so on. So I'm going to accumulate some value. I'm just going to call this accum, which stands here for accumulate. And I'm going to set that to 1 because I'm going to multiply a bunch of things by it. And again, let me just say this again. You don't need to understand how this works right now, but I'm showing you how to break down a problem, okay? So we're going to start at n, or sorry, we're going to start at 1, and we're going to multiply up to n. And so I'm going to say for every number from, 2, or I'll just say 1, even though we're including 1 up here by default. Maybe I'll just say 2 for that reason. For every number from 2 up until that given number n, including that n, we're going to multiply all of those values by each other, right? So accum is going to get multiplied by each number. It's going to get multiplied by 2, by 3, by 4, by 5, by 6, all the way up to n. And then at the end of that, we can return whatever that ends up being. So if I run this, I'm going to print the factorial of 5. And I'm doing this first just to see that it works properly. And it does. Factorial of 5 is 120. I don't know offhand what the factorial of 7 is. Let's find out. The assumption here is that it will work because I made a generalized procedure to solve a given type of problem. So factorial of 7 apparently is 5040. Okay? So, you can think about all kinds of problems in this light, like making a box of spaghetti. You could break it down to its atomic components and, make a repeatable operation for any quantity of spaghetti that you might want to make for your friends. So this is how we're going to think about programming. We're going to approach programming as the ability to repeat some kind of procedure that generalizes to more problems within the same type of problem set. Okay, so let's call it there. We'll talk about Clark will talk about comments in next class. Tomorrow will be Python. Beginning Python, we're going to try to get you up to speed with Python as quick as we can, but we're going to also try not to move too fast. We don't want to leave people behind because we're going at a breakneck speed. And if you are struggling in this first week, please reach out and we will meet one-on-one and we'll get you up to speed. Cool. Thanks so much. Feel free to sign off. If you want to stay on and ask questions of me and Clark, we'll stay on anywhere from a couple minutes to 15 minutes, depending on the demand for answers.